Infinite scroll is a feature that can have a huge impact on the user experience by loading data asynchronously based on scroll position. In this video, I'm going to show you how to implement infinite scroll in Angular with the Firestore database, but we're going to do it in a way that not only allows you to scroll down to load content, but also to scroll up and load content in the opposite direction. This has been a commonly requested feature, and it would be used if you were doing something like Facebook Messenger or Slack, where you load a timeline of messages in reverse. We're going to accomplish this by creating a generic service in Angular, and it will not only retrieve the data, but also tell us when we've reached the end of a collection and when we are loading new data. If you're new to the channel, make sure to subscribe and grab the source code for this project from angularfirebase.com. I'm going to be starting from a brand new Angular app, and its only dependency is Angular Fire, so make sure to go to the documentation and follow the setup instructions there. Then the next step is to create a directive called scrollable. This is going to tell us whether or not the user is scrolled to either the top or bottom of the page. We're going to do that by monitoring the scroll event on the element itself. That'd be the container element. And then we're going to emit our own custom event that will tell us whether or not it's the bottom or top. You can create a custom event in Angular by using the output decorator and event emitter. So our custom event here is named scroll position. Then I'm going to add element ref to the constructor, but I want to warn you that using element ref for direct DOM access can cause issues in Angular with platform server and web worker. We can address this issue by wrapping native elements in a try-catch block, then provide a fallback such as a load more button when the DOM doesn't actually exist. First, we'll set up a host listener on the element, then listen to the scroll event, so keep in mind that your host element needs to be something scrollable. Then we'll set up a function here and put our try-catch block inside of it. Then we need 3 values from the native element itself. We need scroll top, scroll height, and offset height. First, we need to know if the user has reached the bottom of the element. So we can do that by saying top greater than height minus offset minus 1 extra pixel. When that condition is met, we can have our event emitter send out a string value of bottom. For top, we can simply see if the scroll top is at 0. Before we go any further, let's make sure this works in an actual component. So I'm going to switch over to the app component. Then I'm going to import observable as well as the pagination service, which we're going to create in the next step. Then I'm setting up an event handler here that will just console log the event from our custom event in the directive. All we need to do is set up a div, and inside that div, we'll add the scrollable directive. And then for the event, we use parentheses with the scroll position event, and then we'll run our scroll handler. And I'm going to add an extra div in here with some height to it, just so we can actually scroll through this parent div. If you watch the console to the right, you'll see we either get a bottom or top event once we've reached the bottom or top of the element itself. And before we get to Firestore, let's generate a component called loading spinner. Then head over to SpinKit and choose your favorite spinner and just copy and paste the HTML and CSS into that component. Before we build this big complex pagination service, I want to show you how it's going to be used in the component. To paginate in Firestore, you need to send a new query for each new batch of data that you need. The service I'm creating will allow you to make a query with some basic configuration options, and this will populate an observable on the service that we can subscribe to. The first argument to init is the collection, and the second is the field that you want to order by. You can order the collection in reverse, and you can also prepend new items to the beginning, which is what you would use if you were doing an upward infinite scroll. After the initial query, we'll listen for events in our scroll handler. Once we receive the bottom event, we can just call the more method from the service, and that will populate the next batch of items from Firestore. So the service we're building will give you infinite scroll with just 2 lines of code. The service will also give us a data variable that's an observable array that we can loop over with the async pipe. So we'll display some information about our boats in the database, but the service also has 2 other variables that are important. The first one will tell us once we've reached the end of a collection, and that's the done variable. So we can listen for that and then say I ran out of boats once we reach the end. We have another observable that will tell us whether or not a new query is loading, so we can show a loading spinner for each new query, and that also helps us prevent sending multiple unnecessary queries. If we take a look in Firestore quickly, we just have a boats collection that's in the root, and each document has a URL and a year field, so we'll be sorting by the year. When we look in the app, we get the initial loading spinner, and then once we scroll down, the loading spinner will reappear, and about a second later we'll get some new data loaded. Now we're finally ready to start building the service. We're going to need Angular Firestore, and we're also going to make pretty heavy usage of RxJS behavior subjects. Next, I'm going to set up an interface that defines the query configuration options. So we have a required field of path, which is the path to your collection, and then we have the field that you want to order by. Then we'll set default values for limit, reverse, and prepend. Prepend's the important one. That's the one that you would use if you wanted to have the items at the beginning of the array instead of added to the end of the array. Next, I'm going to set up a few behavior subjects. The subjects are all private variables, and they have underscores so you can keep track of them easily in the code. Done will tell us once we've reached the end of the collection. Loading will tell us when a query is in process, and data is the last batch of information that has been retrieved from Firebase. Then we'll set the query configuration as a variable so we can keep track of it between queries. And that'll be typed to our query config interface. Then for each of these subjects, we're going to set an observable that will be consumed by the component. This will keep all of the data changes isolated to the service. This part's technically optional, but it is considered a good practice. All we need to do is call asObservable on the source data. Then the next step is to add Angular Firestore to the constructor. Then we're going to go through a lot of code here, so I recommend checking out the main article for detailed explanations on each of these methods. The first one we'll set up is init, which is going to make an initial query, as well as save our query configuration on the service. It requires a path to the collection, as well as a field to order by, and then it has optional defaults here that you can override by passing them as an object. So we'll set a default limit of 2, and then say reverse false and prepend false. Now we can use this object to make a reference to the Firestore collection. We're going to order by the query field. If the reverse property is set to true, then we'll go ahead and order it descending, otherwise it'll be ascending. Then we'll go ahead and limit it by whatever's set in the query configuration. Then I have a map and update method that I'm going to show you in just a second here. But first I'm going to show you how we define the observable data that will actually be used in the front-end component. So we'll take our source data, and then we'll call the RxJS scan operator on it. Scan allows us to build a larger array over time. If the query options are set to prepend, then we want to take the new value and concatenate it to the beginning of the array. And if it's not set, then we just want to go ahead and concatenate it to the end. Scan is a pretty weird operator to learn, so I recommend going to RxJS Marbles and checking it out visually. Now let's take a look at that map and update method. It takes the Angular Firestore collection and then maps it down to the snapshot that we need, and then sends it to our main data source. If the collection is already done or loading, we don't want to make the query, so we'll just return out of the function. But otherwise, we'll set the loading state to true, and then we'll call collection snapshot changes. To paginate a cursor in Firestore, you have to use the document snapshot. So what we're going to do is map down the array to the data that we want to show on the front end, as well as the snapshot. You'll see in a second here how we use the snapshot to offset all future queries. Then after we have this data mapped down, we're going to check and see if the prepend option is set. Then we need to reverse each individual batch to maintain a consistent order going in reverse. There may be a better way to do this, but I wasn't able to figure one out for the upward scroll when you're prepending new items to a list. After we have the values mapped down, we'll go ahead and update them in our main data source. At this point, we can set our loading state to false, and we can also check to see if that was an empty array, at which point we know we have reached the end of the collection. And this is going to be a one-off operation for each new query, so we're going to say take one and subscribe. This will end your real-time connection with Firebase, but pagination with real-time data introduces a whole other host of issues and trade-offs that you have to think about. It's beyond the scope of this video, but please reach out on Slack if you want to talk about it. Now we're ready to set up a method to make secondary queries. So first we need to know the cursor that we want to paginate from. If we're prepending, we want the document snapshot from the first item in the last batch. Otherwise, we want the last item in the last batch. If the array is empty, we want to return null. Otherwise, we will get an error from Firestore. The more method is going to make all subsequent queries. First, we need to get the cursor for the pagination, and then we'll create a Firestore collection reference. It's identical to the initial query, except that it uses start after and passing the cursor as an argument. This tells Firestore where to offset the query from. Then once we have that set, we can call map and update, and our data source will be updated. That was a lot of code to get through in 10 minutes, but make sure to check out the full article for detailed explanations on all of these methods. My goal is to give you a generic service that can work with any Firestore collection and give you infinite scroll either upwards or downwards. That's it for Firestore Infinite Scroll with Angular. If this video helped you, please like and subscribe. And if you want twice as much content every week, consider becoming a pro member at angularfirebase.com. You'll get exclusive content, a free copy of my book, and one-on-one project consulting. Thanks for watching, and I'll see you next time.